Thank you. So it's a pleasure to be here. It's always a pleasure to be at Tirreno because there are so many old friends here. It was a pleasure to arrive this time as well, after a somewhat complicated journey. François, I missed one announcement. I saw on the web this morning that the Aer Lingus dispute was settled overnight, so they're supposed to be flying again by tomorrow, maybe even a few planes this afternoon. So that's good news if you want to go home. Okay, I've got a lot of slides, so I better get started. I want to talk about the Internet today a little bit and what I see as the challenges, otherwise known as problems, that it faces today and the barriers that are in place today. I want to talk about the Internet tomorrow and how it's going to evolve. And then I want to talk about releasing the known potential and tearing down the barriers. And this is a talk more about middleware than about infrastructure, but I think it bears very much on what the infrastructure has to do, so I hope Fred will tell us afterwards how it's going to do it. Okay, this is a sort of marketing slide. I didn't make this one. All sorts of logos and pictures. The point is to indicate where we have got to with the Internet at the moment. We have got to the Internet being fundamentally an information-providing service. It's moved from just being a network where people did email and online chat and so on to being an information service, and that was, in fact, the CERN contribution, because the first part was done by ARPANET and friends. And certainly the IBM view, this isn't an IBM talk, but the IBM view is that the Internet is the foundation for e-business as a result of having got to this stage of an information web. But what we really have is an information web. The image I have is that the normal mode of use of the Internet today, whatever scientific and technical people may think it ought to be, right? The normal mode of use for the vast majority of users is just sucking down bits from a server, right? Exactly the same model as young birds suck down bits from their parents, which is why I went and looked for this picture. I mean, you've heard of webcams and nannycams and jennycams, but I'd not heard of a Nest Cam before I went out on Google to look for this picture. Using the web to do stuff is still rather the exception. You know, it's growing, but it's still not a common mode of usage. Using the web on the move, literally on the move, is very much still the exception. And we all know that WAP has not been an overwhelming success. Fully trusting the web is still the exception. And this concept called web services is just starting. The point about web services, and this is important, I think, is that it's not a client-server model anymore. You do in web services have the concept of a service requester and a service provider and a service registry. But an object which is a service requester at one moment may well be a service provider the next moment. And when the service requester on the left asks the service provider on the right for a service, that service provider then may itself go off and request the service from somewhere else. That's the sort of model about that web services is beginning to bring in. And, you know, it has a software stack. And what I find interesting about this software stack is not so much the details, you know, and the acronyms, as the fact that the very bottom layer of this software stack is this thing called network. And if you look at the acronyms in that thing called network, it's the whole of what I thought was the Internet until I saw this picture. In other words, people building, you know, trying to build business services using this technology just regard the network as we tend to regard electricity and gas and other basic services. They don't care whether HTTP is a good or a bad protocol. They don't even care who invented it, right? It's just a thing that they use. And there's a lot hidden inside that, etc., at the end. So I find that interesting because it means that everything that most of the people in the traditional Terrainer community have been worrying about traditionally is just consigned to this very bottom layer in the stack, which people think is a solved problem. Well, okay. So I want to talk about the challenges and barriers that there are in the internet today. Some of you may have been at the Nordernet conference in April and have seen some of this material, except there it was called problems, because I was asked to talk about problems. But one of the first things I learned when I moved to industry is you're not allowed to use bad words like problems. So for today, they're challenges. Success, scaling, thoughtlessness. Those are the three types of challenge that I think we've encountered. Okay, first challenge of success was, of course, the arrival of the gold diggers, the gold rush. This is a very interesting quote. The commercial domain grew by over 10,000 in the first 2 weeks of August. Kraft Food registered 133 product names. Procter & Gamble started registering ailments, afflictions, and body parts, e.g. diarrhea.com, pimples.com, and underarms.com, and 36 more. Okay, guess the year. Anybody want to guess the year? August of which year? Yeah. 95, right on. So that's a long time ago, isn't it? And the world has changed several times since 1995. But this message, which I received in August 1995, really told me that there was something fundamental happening, that was completely new, had never been seen before in the internet. And by the way, this was the beginning of the trend that led to Larry's talk yesterday, because it's only because of the gold diggers that we ever got to that point. By the way, interesting thing, that URL, which was the original source of this message, of course, is now broken, doesn't work anymore. Diarrhea.com, pimples.com, and underarms.com are still very much alive and well. I checked them just recently. They lead you straight to product descriptions for fixing these three problems. Okay, second challenge of success, which again resonates a bit with what Larry was talking about, regulators and politicians. Very simple. Regulators find the internet very tempting but hard to get hold of. When in doubt, make a regulation. Politicians also find it very tempting and quite threatening. And politicians are unpredictable, even more unpredictable than regulators. So when in doubt, pass a law. And never mind these techies who say that's impossible, pass the law anyway. And we've seen a number of cases of that. ICANN, challenge of success, because we wouldn't have needed ICANN if the internet hadn't been a success. But it does strike a number of us as odd that it can possibly need 30 staff and $6 million to perform these four relatively simple functions. But apparently it does need 30 staff and $6 million. Another challenge of success is hubris. I looked it up. Derivation is from the Greek. It means exaggerated pride or self-confidence. And it's true that a number of people who have been involved in the internet from the early days do show signs of believing that they have unlocked the secret of the universe rather than simply inventing a piece of cool technology. So we certainly shouldn't lose sight of the real problems and should not ignore the impact of success on the original design principles of the network. Because there's no doubt that the success of the internet has had a strong impact on the design principles. Another challenge of success is internationalization. Those of you who saw Harold Alvestrand's presentation in a parallel session yesterday saw a great slide on this. We thought it was fairly straightforward. You just rely on the ISO standard for international character sets. But it turns out that there are two kinds of usage of text. Some usages of text are completely hidden inside protocol elements, and they only have to be read by machines. Other uses of text are intended entirely for human consumption, only have to be read by humans. Neither of those are really problems. The problem is when a piece of text is in between those two extremes, and sometimes needs to be read by a machine and sometimes needs to be read by a human, because that turns out to lead to conflicting implementation requirements. Humans can handle ambiguity. Humans care about cultural aspects. And because of that, the way you have to match two pieces of text to decide if they're equal is different according to whether it's a machine that's looking at them or a human that's looking at them. And that leads to some very, very tricky problems about which people get very emotional. Okay, moving on to the challenges of scaling, which of course derive from success. It's very simple. We've known since 1992. This is the 10th anniversary year of knowing that we had a scaling problem for address space. We chose the solution in 1994. There have been products since 1997. The standards have been stable since about 1999 or 2000. So why is it so slow? Why is IPv6 so slow to start? I think there are three fundamental reasons: operational costs of conversion and conservatism on the part of operations people who don't like change, which I understand, since I ran a network for long enough to understand that very well. There's a clear lack of strategic incentive because the internet industry is a short-term industry and IPv6 is a long-term requirement. And finally, the pain from the alternative, network address translation, is spread too thinly, and that pain is not applied to the decision makers who take these big decisions. That pain is applied to operators and people who have to configure boxes in and out every day of their lives. And they're not the people who will be taking the decision to migrate to IPv6. Another challenge of scaling is well known: the backbone routing system. Also been a known problem since 1992, but I believe it's far harder in principle than scaling the address system. There's an RFC about that, written by Jeff Houston. It's my belief that BGP4 or BGP4 Plus is not adequate for much longer unless somebody thinks of a really neat trick that hasn't been invented yet. Unfortunately, this challenge is still a research topic. Okay, I had to show you the curve because everybody shows Jeff Houston's curve. That's the BGP table size on a linear scale. It's not a log graph, on a linear scale over the last, since 1989, a number of years. And you can see that there are steeper bits and flatter bits. At the moment, according to your imagination, we're either on a flatter bit or we've just gone back onto a very steep bit, depending on how much you want to extrapolate from short pieces of the curve. But the fundamental point is this is still going up, and we don't know how to stop it going up as the network expands. And that's the scaling problem we need to solve. Another challenge, which I believe is fundamentally a challenge of scaling, is quality of service. We've invented solutions, RSVP and DivServ. They're both available in widely used products, and neither of them has swept the world, which is an interesting situation. It's a bit like IPv6. How can we get a new technology into the current practice of every network operator? Because there's no doubt that there's a lot of people who want some kind of quality of service. There are still a lot of detailed technical challenges there. Jeff Houston did another RFC a year or so ago, 2990, which I think is still a very useful description of the challenges in quality of service that haven't been met. Oh, another challenge of scaling is standards organizations. This is a list of standards organizations. You can't read it. In fact, it's sufficiently small that I can't read it even on the monitor down here. There are an amazing number of organizations which claim to be doing standards work or standards-related work around the Internet. The first one on the list is, of course, the IETF. The second one is the W3C. The third one is the Global Grid Forum. And then it continues. And this is actually a significant challenge for a company, particularly a small company. How the heck do you deal with this level of complexity in the standards world? Okay, third kind of challenge is thoughtlessness. Okay, you should always remember to put the handbrake on when you get out of your plane. Right? This was Los Angeles about a month and a half ago. Apparently, they didn't put the brake on. The plane just rolled across the road. Nobody was hurt, but, don't be thoughtless. So I think we've been thoughtless in the Internet a number of times, and network address translation is a clear example It was a tempting quick fix. You could even market it as a security system by pre-configuring the box to allow nothing, then of course it's a security system. And it happens to break lots of applications that are not classical HTTP-based client-server applications, and it breaks IP security in its current form, although there is some work being done on a workaround. Lots of polemics on that in the IETF. You can read RFC 2993 if you want to see some of the arguments behind the polemics. Another challenge of thoughtlessness are what I call layer violation boxes, what the people selling them call level 4 switches or level 7 switches or things like that. Let's just peek into the application layer headers. Let's just send this packet to a different server, not the one it thought it was going to. Let's proxy this HTTP request without being asked to proxy it by anybody. Let's just rewrite this little piece of the packet. You know, all these things are in products. They're all very tempting quick fixes. The result is unpredictable glitches, unpredictable failures that people just don't understand, and you cannot get a help desk to resolve because they don't understand what's going on. There's an RFC about that, RFC 3234, which I wrote with a colleague. And the conclusion is that these devices that sit in the middle of the network, which we're tending to call middle boxes, they need to be architected, not just thrown together in a thoughtless way. Another challenge of thoughtlessness, let's just put it in the DNS. The DNS was quite narrowly designed, basically to get rid of the etc hosts file. It was designed to be extensible. That was perhaps a mistake, because it was not designed as a directory. It has been abused as a directory. Pimples.com is a good example. It's absolutely not what the DNS was designed for. And it still isn't secure. There isn't an RFC about that exactly, but John Clenson has a draft out talking about the role of the DNS, what it should be and what it shouldn't be. Security people are addicted to the crunchy outside, soft inside model. Corporate firewalls try to keep the sheep from the goats. It's a broken model because it's very vulnerable to dishonest employees. It's very vulnerable to tricks with supposedly safe protocols. Run IP over HTTP, for example, and you can punch through any corporate firewall. And it doesn't meet new requirements for compartmentalized trust relationships, or what I think is very important, any-to-any trust relationships across administrative boundaries, where any two parties may need to trust each other, even if their companies don't trust each other. Another challenge of thoughtlessness, let's just run it over HTTP. HTTP was also narrowly designed to carry HTML. Firewall operators are bound to let it through, but it was not designed as a transport protocol. It's been abused as a transport protocol. The example I just gave, IP over HTTP, is the classic abuse of HTTP. There's an RFC about that, RFC 3205. Oh, and there's the mythical PKI. I'm not attacking the concept of PKI or the people who worked on it, but it was thoughtless to imagine that just by creating this technology, we would cause a genuine public key infrastructure to come into existence. We don't actually have a public key infrastructure at the moment. It's a very big challenge, except within a closed world such as a single company. So what did all those challenges do to the internet? They created barriers to progress beyond this client-server information web stage. You know, the middle boxes inhibit the deployment of any-to-any solutions as opposed to simple client-server solutions. The firewall security model and the lack of a PKI inhibit the deployment of any-to-any trust models and therefore really fine-grained security. There will be solutions, at least to some of these problems. IPv6 is ready to roll. We have work going on architecting the middle boxes. And I believe trust models for any-to-any computing will emerge, quite possibly in the grid form. So, the internet tomorrow. It's going to continue to change and to grow. I'm not as pessimistic as Larry. I think the internet does root around damage and will continue to do so. Marketplace wants more efficient use of resources. It wants industrial strength, infrastructure. It wants integrated solutions that are also flexible In other words, you can't get an answer whether the solution should be centralized or distributed because it depends who you ask. So it needs to be flexible. And we have, of course, impatient consumers who want the internet to have all these wonderful properties listed at the bottom. Fast, always on, and so on. Growth will not slow down. There are cases where bandwidth costs can beat Moore's law. The current state of the telco industry makes that a very dangerous statement because you may think you've got a deal that beats Moore's law, but the next day the company doesn't exist anymore. And I know several people in the room who've had that problem. New countries are showing an interest: China, India, Korea, just 3 examples. I believe we should bet on 10 billion nodes. I think that's the target we should have in mind for the internet, 10 billion nodes. We got this culture of standards, buzzword slide, won't waste time on it. We've got a big convergence in trends in industry. The web services I talked about earlier, grid computing is a theme of tomorrow, so I won't talk about it. But these big movements were driven by the same underlying forces: the evolution of the costs of components, convergence of systems. For example, there's only going to be a couple of operating systems in the world in a while, I would think. The importance of resource sharing, the importance of service levels as opposed to just best effort, and the importance of security. So these trends are the same in scientific and technical computing as they are in business computing. So the vision that a number of people have now is the internet is going to be a computing services platform. It's not going to be a communications network. That's where the Open Grid Services architecture concept comes from. I won't spend any time on that because I believe Ian Foster is actually coming, because he wasn't on your list of people who's not coming. So he's going to talk about that tomorrow. We also need the infrastructure itself to be self-managing or autonomic, and we need to be able to use this infrastructure as a utility like the gas and electricity, because that is actually what the user community, at least in business, seems to want. So here's the marketing version of that slide. Glorious future. It's not quite trivial. It's hard to imagine deploying OGSA or any other generic services architecture where any system can talk to any system across a network of 10 billion nodes without removing the barriers I talked about earlier. You know, I'm short of time, so I'm going to have to rush through this, but, you know, if we remove some of these barriers, we can make voice over IP work without having to spend half its time twiddling around to avoid NATs. We can make 3G cell phones start with a clean addressing and routing scenario for internet on the move. We can stop using HTTP as a Trojan horse and do a proper job of building web services as an end-to-end service. And the benefit of that is that e-business goes into every small and medium enterprise, and you're not a business audience, but you do need to care about this because this is what's going to drive the technology. Distributed and virtual enterprises, we need to get rid of the barriers so these virtual enterprises can have proper security. Trivial point, if you merge 2 companies today and they both happen to be running Net 10 internally, it's horrible. It costs you millions of dollars to fix that problem. And we need to enable massive scale grids and generalized e-utilities, because then everybody wins economies of scale. I believe we need to get rid of the barriers so we can network the homes and schools properly. Entertainment becomes on demand and largely interactive. I'm hoping the problems that Larry Lessig detailed will have been fixed before then. Same thing for education. And, you know, I think we need to get information technology everywhere, basically. If you want to build interactive groups for learning or for playing, you need peer-to-peer transparency throughout those groups. And I only know one way to do that, which is to get enough addresses. And it's a bit shocking that such a tiny percentage of the world population has internet access. There are various guesses of what percentage that is, but it's just a few percent. I believe our collective aim, as people who believe in the internet, should be to get to all of them, that everybody have access to the internet. That actually makes the market 20 to 50 times bigger if you look at the numbers. It's good for business, but I believe it's fundamentally very good for society to do that. You may have gathered by now that I'm a fan of IPv6. I just don't see any reason why we would try to put 10 billion nodes into 4 billion addresses. But I think we should go for 10 billion nodes. There's immediate benefit of doing that, of course, for the applications that are annoyed today by NAT. But there's a strategic benefit for the next 50 years at least in avoiding the opportunity cost of staying with IPv4 and its restrictions. The barriers aren't permanent. As I said before, IPv6 is ready to roll. We're doing work on architecting middle boxes, and trust models will emerge that work in this any-to-any mode instead of just the company-to-company mode. So we've got to web services just about using IPv4 and some kludges. I do believe that as growth continues, the Open Grid Services architecture or something somewhat similar to it will transform the internet into a computing platform, but it will get stuck on the rough edges of things like NAT boxes and firewalls and the layer violation boxes. So I think as a community, we need to tear down those barriers over the next, say, 5 years. That's all I have to say.
Thank you, Brian. So I suggest we move now directly to our second plenary speaker, and it is a pleasure for me to introduce Fred Baker. Fred Baker is a Cisco fellow. He served as IETF chair from 1996 to 2001. He also now serves on the IETF Internet Architecture Board, the IAB, and he was recently appointed a member of the Board of Trustees of the Internet Society. Fred, the floor is yours.
Thank you. I want to apologize for showing up in the same shirt I've worn for the last, since Saturday. My bag hasn't made it through the national firewall. But, I want to talk with you today a little bit about where I see research needing to go and where we need additional experience to build the kinds of things Brian pointed out needed to be done. I'm sure my company would like me to stand up and say, just buy Mumble from Cisco, and let's not do that. So let me start out with the economic news, kind of set the stage a little bit. The economists tell us that we're starting to come out of the recession slowly, which is actually good. If it came out very quickly, then it would probably just go flop again. But slowly and building with some strength. And that appears to be a true statement, that there's some strength in that. Now, what they tell us is then that over the next few months, we should expect to see the enterprise market starting to grow stronger. And service provider market should then pick up as the enterprise market buys more services from service providers and pushes their networks. Now, what does that have to do with the National Research and Engineering Network? Almost nothing, except that the questions that I start getting by service providers come back to be the things that you are going to have to worry about next. Some of them you're dealing with now. And we're going to need solutions that you've tested out in the great wide world for people running commercial networks. So this becomes places for you to go play. Now, what service providers asked me, a couple of weeks ago I was in China and literally was asked this in so many words by China Telecom and any number of other companies. They said, we're seeing new applications coming out. What we want to find is applications that fit into our service models and which will drive more bits across the network and will therefore drive our ability to charge money. If I can't do that, how can I make providing that service cost less so that I can make some profit in between? For example, I was at a cable provider in New York a couple of weeks ago, and he said, you know, these people have come up with this application called Nutella, and traffic, and another one called Morpheus, traffic goes out through my network. I can't charge under my service models. I can't charge people for that traffic, but it costs me upstream when it goes out to the commercial network. And so how can I come back and do something to manage that traffic in a way that, that my users are going to accept, and so that I can remain in business? And so I find myself thinking, okay, if I'm a service provider coming out of the economic mess that we've been in for the last year or two, and looking at network design technologies and the issues that they're facing, where am I going to be going, and what technologies am I going to be looking at for my next purchases, for my next network plans? And I find that the things that I'm going to be looking at as this prototypical service provider is basically, how can I do more with less? How can I make the bang to buck ratio play well for me? Now, these next generation applications that we're looking at take a very different character than applications that we've had in the past. The ones that we really drove the success of the internet based on, as Brian said, were web services using HTTP, file transfers coming from file servers somewhere, all client-server model kinds of things where somebody at some random device is going to go to a server, is going to download something, and something's going to happen. But, you know, I don't see that in the applications that my kids are playing with. When I walk into my son's bedroom, he's sitting there on his computer that he worked 100 hours at my house and went out and bought, and he's playing some game. And this game involves a flight simulator kind of scenario, people wandering around, shooting at each other, and jumping through hoops and doing stuff. And he has no idea, and by the way, I don't either, how much bandwidth he's consuming on the network. He doesn't realize that that might be an issue. He's just out there playing around. He's doing what he does. And this is the kind of thinking which is driving these new applications, which will in fact, therefore, drive bandwidth growth. And what that tells me is that we have a mismatch in the service models that the service providers are putting together. The one that they deploy today is essentially an entertainment model. It says, I have the content, I will serve it to you. But the application designers, the people that are driving new applications today, are saying, we really don't want to talk to you. We want you out of the picture. We want to provide the content ourselves. We want to talk to each other. We want to do what it is that we're going to do. Can you facilitate that? And we have to look at business models and technological models that will support that and will allow us now to make networks that work using it. What that means is that we have a bit of a dichotomy in how we're using things. If I'm depending on the client service model to keep worms and viruses and bad things out of my network, fine. But as we move into this new world, we're going to find that that doesn't protect us. And so we have to find authentication and authorization models that in fact allow us to do peer-to-peer networking without exposing ourselves unduly to the bad things that are out there. To do that, I have to ask myself, okay, so what are these new applications and what new requirements are they going to be? Am I going to have to signal directly, not to a server, but directly to my peer in a game? Am I going to have to, do other things? And can I control what's going to come to me? Anybody who's been watching the KLEZ worm lately has probably wished that they could go over to the other machines and say, just don't send me this email. we're going to ask ourselves, we're going to have to ask ourselves, how can I control the content that someone gives me before he gives it to me? Have him tell me, I want to present you with a certain kind of content, and have us to decide, well, maybe I don't want that. The access control issue to which I was referring winds up looking something like this. If this is my kid's game, you know, I've got 30 kids around the world that are all using some central server, and they're talking to the server doing something. That works in today's client-server world. But it means that you have to have a very high-performance server in the center, and it means that this 1.2 gigahertz computer sitting on my kid's laptop, or on his desk, is effectively a display device, which is kind of silly. In order to facilitate much better use of those resources, we're going to have to provide safe environments where they can play in the network and they can talk directly to each other. What that means, of course, as Brian pointed out, is that they can't be behind, as my son's server is, or computer is today, can't be behind an app. It has to be in something that's directly addressable. And we have to then be able to have some central device that will allow them to know who they may talk with and what things they can accept from each other. They act essentially as an authentication server for them. But to scale much better than Kerberos or similar infrastructures would give them, have to operate on a global scale. That technology has to operate across perimeter boundaries, has to operate well enough in terms of intrusion detection and authentication to keep out the bad guys and to make bad things not happen. Make it be okay for me to expose my kids on the internet. That's, you know, for mom and dad or for the university master who's controlling what's coming into his campus. That's a big concern. And that will ultimately limit, if not handled properly, ultimately limit certain areas of the growth of the internet. We, of course, have to manage the IPR issues. Larry basically said yesterday that the DMCA was a bad idea, and we should simply, you know, get law out of the realm of the internet. I about 80% agree. At the same time, there is a proper role for law. There needs to be some balancing there where we say, okay, but let's see if we can find ways to make people who don't really know or care about law be able to have their interactions controlled by those who do, so that the parents don't wind up liable for something. And we have to do that in a world in which there's no PKI. There's simply not going to be one. Now, in the context of that, I've been, the last few months, the chair of a working group in the IETF which deals with internet emergency preparedness. And what I've found myself dealing with is a set of people who run truly amazing networks. I was sent a note last night. Would I please consider working with NASA on a networking technology for a cluster of devices moving in interplanetary orbit so that we can network among those devices? That's an interesting and unusual kind of network. I spoke with a fellow from Fort Monmouth, which is R&D for the Army, U.S. Army, a couple of weeks ago. Yeah, and he said, I have people in the world whose lives depend on them literally being able to send an instant message and get a response back in a period of seconds. And they have low bandwidth availability and high delay. They have 2.4 kilobit links attached to their helmets. And they're out in the bush. And I said 2.4, and he said, yeah, 2.4 when it's working well. We have other people in the world who run around on ships, and ships have, turns out, much higher capacity links than the soldiers off in the bush. They have 16 kilobit links with type 1 encryption. or maybe 64 on an aircraft carrier. And we're now going to communicate. And by the way, I love this. I had an explanation the other day of how, if they're moving a ship from Norfolk to Bahrain and it's moving through the Mediterranean, how the signal goes. Somebody says, you know, could I please open a TCP connection so I can send an email? So he sends us in, right? Well, let's hear it. It goes from the ship via satellite to Italy. It's backhauled on a fiber channel to Norfolk. Gets pulled up to something which looks and says, oh, the application that this is wanting to talk to is in Bahrain. So it takes a satellite link to Europe, takes another satellite link to Saudi Arabia, and then it takes a fiber channel from that place to where the application is located. And, oh, you wanted the SYNAC? We have people coming to us with infrastructures that they have existing and want to convert to internet infrastructures and be able to use in order to accomplish their goals. And they're writing standards such as F706 and the I225.3 MLPP model, which allows them then to take their existing telephone-based infrastructure and literally overlay it on the network. And when I talk with these people and say, well, you know, this is an IP network, you're probably going to have to deal with file transfers and this, that, and the other that your voice will interact with. And they'll say, oh, really? I wasn't planning on that. I'm building this network for voice. And it's going to be all voice on IP. Not that that's never been done before. We have 3 national networks in China that are running all voice and IP, run by China Telecom, China Unicom, and China Mobile. You can literally, on the streets of Beijing, walk up to a payphone, punch a card in it, and have a voice on IP conference to anywhere within 30 major cities in China. Okay? So these people are very serious. They're looking at it and saying, voice on IP. That's what I'm building this network to do. Now, 2 or 3 years ago, I visited an agency in the U.S. White House which is called NSTAC. NSTAC has an interesting environment. They have a telephone switch downstairs from each of our national voice carriers. And in the event that, you know, something comes flying over the horizon, their operating orders are to run down in the basement, punch a button, and now own the telephone network and defend our country. They asked me to brief them on the internet. So I came and said, well, what's your question? Their question turned out to be, where's the button? And so I drew this picture for them and said, it's a little bit more complicated than your average phone system. They looked at that and said, where's the button? The objectives that they have for these networks that they're putting in place, I pulled out of a recent internet draft, which has since been updated and these things went away. But, okay, so these are the things that they say that they're looking for. Many of them look fairly standard, fairly straightforward, except that you have to understand that the people who are writing this use the word transport to refer to the physical layer. And so the words all have different meanings. For example, when I talk about preferential treatment, I think in terms of a queuing discipline. I think in terms of saying, this packet goes next. And, oh, no, they don't particularly mean that at all. They'd like to have that. But what they mean is, I'm a person, I get preferred. You know, this World Trade Center just went plop, and I'm the fireman, and I'm running in, and I need to go do something. And could you please make sure my call gets through? And they want to apply that same model then to instant messaging and to other applications. In New York on September 11th, well, probably on the 12th or the 13th, AOL came up with something on the order of 60,000 BlackBerry units and just handed them out, said, take them, use them, do what you need to do. We'll discuss the details, 6 weeks from now when you get done and want to come back. And literally, gave their instant mail network or instant messaging network in New York to the emergency services. And the same thing was done by any number of companies in terms of different aspects of networking to help deal with the mess that came in there. Telephone networks simply didn't work. What did they use? NiserNet, voice on IP. NiserNet became a voice on IP network overnight. On September 13th, there was a telephone call between the New York governor and the New York City mayor and the president of the United States, and that was on TV. The telephone they used was a Cisco voice on IP telephone. Okay? That's how telephone calls were made in New York during those weeks, was voice on IP. He said, I want my network to be secure, looking at the emergency telephone network. And I said, oh, what does that mean? Does that mean you want pressurized fiber? Does that mean you want type 1 encryption? What does that mean? And Hal came back to me and said, well, what I really want to know is that the person that I'm talking with is the person I think I'm talking with, and that the messages that I send to him get to him and don't get garbled in flight. I want to know for certain that things that need to be kept private stay that way. And I need to be able to control the use of bandwidth, be able to say, you know, I'm whoever I am, and having authenticated that I'm this important person, I want to now be able to get the bandwidth that I need to do what I need to do. Authentication and authorization for emergency services has to go end to end, from person to person, from point to point, not from network element to network element, which is the way that they go now. That becomes a driving requirement for something which can actually address end to end without having to worry about translation. They worry a lot about interesting routing. Interesting routing might mean on a telephone call that I have national priority and therefore permission to use a national network that the normal person can't get to. I'm a military person, so I use military networks. I'm the CIA, so they let me do whatever it is that I need to do. They want authentication, which to me has some sense of knowing who you are. They want non-traceability. I don't really want to know who you are. How these relate together, I don't know. But they're looking at requirements for particular applications and for particular users that include routing traffic in interesting ways, losing information when necessary, adding information when necessary, and, by the way, using any number of networks that we don't even think of as normal networks. And it has to work everywhere. When they talk about mobility, they're not talking about 3G cell phones, though that's certainly one of the things that's on their mind. What they're thinking about is, can I pack an office into an airplane, put it in a parachute, and deploy it somewhere? Can I set up an emergency office in a park and be able to deal now with thousands of people coming out of the woodwork to say, my building went flat? They need something that they can transport and deploy and bring up very quickly and very easily. Now, I don't know how many of you go to shows and do demos. I find myself at Interop and places like that doing a demo. And when I do a demo, I start out by staging the thing for weeks in advance, making sure I know how the printers really talk to each other. And then when I get there, I expect things to fail. I expect things to not work. They're saying, I'm sorry, no. We're going to deploy troops using this. We're going to deploy people who have to deal with masses of people and for whom the very last thing they want to hear is, oh, the printer's down. Okay? It has to work when it gets there. Mobility is beyond just motion. And I'm continuously asked about survival under load. Now, these people, of course, are coming from the telephone side of the world, and their experience is that networks fail when loaded. The fact is, on September 11th, the network that worked famously was the internet. When the towers came down, they took with them 2 AT&T switches in the building. They took out a Verizon switch in the building next door. And that affected telephone calling capabilities in the United States as far away as Chicago. Made it very difficult to place a phone call for a period of weeks. In the course of that, we took a number of fiber cuts, and we lost the ability to manage a fair portion of the IP network that was around there too. But of course, IP routes itself. BGP takes care of this. And the IP infrastructure, we really didn't notice a change. You know, routing changed, we went on about our business. But we're asked, this has to be able to survive extreme loads. It has to be able to reroute rapidly. And it has to be able to survive. And by the way, reroute preferentially. And what are the target services? Well, they're all the things that we do now, and plus whatever it is that they think of in the future. But for them, the first thing they think of is voice. An interesting point, if someone came to me and started talking about network requirements, one of the first things that I would ask is, so what speed do you want to run? What are your speeds? What are your feeds? How are you going to tie this thing together? That doesn't even come up. They want scalable bandwidth. They want to be able to use whatever's there. That's all they ask. You know, can we use whatever's there? Their idea of reliability, though, comes from the telephone network. And one thing the telephone network does do is when it's working, it works extremely well. They're looking for the same kind of reliability and availability from the internet that they are used to from the telephone network. So now there's a number of key technologies, some of which exist but are in experimental stages of deployment at this point, and some of which really don't exist yet, or at least not in the form that they need to be, I think. So let me talk about those and suggest that this might drive research interests. It might drive deployment interests, might drive some of your activities over the next year or two. One of the things that we're finding commercial customers, military customers, networks of various kinds coming back and asking us about is, can I please route the voice traffic a different way than I route the data traffic? Can I route file transfers differently than I route other things? This is the fish problem. And you've all looked at it and you've all seen it in various ways. But this becomes, they want to look at it specifically at the IP layer. When we're talking about 2.4 kilobits from a soldier's helmet to his base commander, we're not talking about wanting to add an MPLS header to it or another IP header. We're looking at wanting to be able to directly route the IP that's there. And by the way, without the additional cruft of on-the-spot policy-based routing. Rather, can we do something that is systematic, something that's provably correct, something that's built into the protocols? We find ourselves asking, maybe we need to go back, I think it's RFC 1583, where OSPF described types of service routing, and look at routing diff-served code points. You know, overloading onto diff-served code points, the idea of a traffic stream that might be routed differently than something else. And we're also looking, of course, at security in routing. Can I be sure that it's the good guys giving me the routing information and not the bad guys, whoever the bad guys might be? They're interested in the context of the fish problem, in virtual private networks. They're looking at various ways that one might use networks in order to provide the very specialized services that emergency services, military services, high reliability services might need. So they're interested in looking at VPNs. The big problem that they look at with voice is not, does voice work? They believe voice does work. In fact, they demonstrate that it works quite well. Question becomes, does it interoperate with the SS7 network that we have deployed today, and which remains the lion's share of the telephone network? Can we, for example, when a person calls in a bomb threat, hit star 59 on the telephone, hold up the call until someone can come in and trace it? That's something you can do on ISDN. Can we do that in the voice on IP network that we're deploying today? Answer, no, it's not there. Can we carry the different signaling priorities that are built into SS7? Can we look at each of the different message types, the different services that are deployed over SS7, carry them through a voice on IP network from one part of the PSTN to another? Or can we originate those calls in a voice on IP network or terminate them there and carry them across into the PSTN? Can we use the voice on IP network as an extension of the telephone system, or does it have to be, as it is today, an entirely different system that we put in parallel? They're looking at it and saying, I really need to integrate this with the phone system, and I need then to be able to phase the phone system out over time. I know I'm going to IP, but I can't simply buy the whole thing and replace it. That's not one of the options. I mentioned security. Security comes in various ways. We're going to need strong authentication, strong authorization. We're going to need that at various layers. But for security, for these people, they're also very concerned about resilience to attack. Today, when we come under the denial of service attack, what happens is that, 5 hours after the thing is started, somebody notices, and maybe a telephone call goes back and forth. And what we'll do is we'll take the traffic which is directed to a system under attack and discover, pull it aside and verify what it is and think about what it is that we're going to do. They're saying, if that is deploying troops, if that's deploying fire engines, if that's deploying ambulances, we can't be doing that. What we need is for the network, the service provider, to actually make that kind of traffic not come through, to detect it for us. And at minimum, tell us within a few minutes an attack has started and you need to be aware. There's room, I think, for a service offering here, for the service provider to actually offer that as a service and say, pay me money and I'll give you that phone call. Of course, what that means is that he has to deploy products that do that as well. Brian mentioned the need for a scalable public key infrastructure and the fact that we ain't going to get one anytime soon. I claim that there's a way to do it, but what it's going to require is for us to find a way to move all the information out of the database that the PKI depends on, actually in the end user's node, and have that central authentication agent simply be a decryptor, something that is stateless and memoryless and actually knows nothing about any of the people that it talks about. There are some research experiments going on. I was talking with John Crowcroft and some other people yesterday about exactly this kind of thing. We need for this to be made to work. If not this, then a better idea, and provide a way that we can actually authenticate people in a scalable fashion on a global basis. And then there's lawful intercept. And of course, I'm sure every one of you has had your friendly local law enforcement agency come out and offer to help you find criminals in your network. What we're finding is that now every country in the world has very specific requirements in this area. The Cybercrime Treaty, which was signed last November, I believe, now tells us that we need traffic data on traffic going through every service provider, which ultimately will include your networks. And I have to ask myself, what are they trying to get to? What do they really want? I spoke with the BVD about this in Holland last January when I was here, and told them, listen, the service providers do not run NetFlow on every session going by. And they said, well, we don't actually want that. We know that service providers keep some statistics for the purpose of provisioning. It All we want is that information that they already collect. But you realize what they're asking for. When Tony Blair made the famous talk about 70 reasons why the United Kingdom needed to support the United States in attacking Afghanistan, points 35, 36, 38, and I think about 68, related to information that they had gotten from intercepts and dealt with the fact that somebody had called somebody who called Osama bin Laden, who called back, who called this person back. And if they're going to do that kind of thing based on provisioning data, I'm sorry, I don't think that's going to work. So I have a feeling we're going to have law enforcement coming back to us and wanting to find ways to know traffic data that would allow them to do that same kind of analysis. Do we have to go solve problems for them that they're not asking for yet? No, we don't. But I think we can honestly predict that they will and need to be asking ourselves how we're going to solve that. Of course, we already have the problem that we have to be able to collect content and deliver it to people. And, you know, things are in the works to make that be a capability. Now, this is just one final slide. For many of these things that I've pointed to, the technologies exist, but they're in the early stages of deployment. They may not be very scalable. They need work. And as a research and an engineering organization, I should think that we can turn to you to do much of this research, to try things out, to tell your vendors what doesn't work, to work out solutions that will in fact play. For some of these technologies, we need new ideas. There are no quick fixes here. But these are things that have to be done in the infrastructure, I claim, in order to support the kinds of services that Brian talked about in his talk, that new application network development is requiring from the internet community, and so on. So we need to work together on the research in this area. So thank you.
Thank you, Fred. Well, we are going to take questions from the floor, but before that, I would like myself to ask 3 questions to our speakers this morning. One which will be more directed to Brian, but Fred will be welcome to also comment. The second one more to Fred, but Brian will be also welcome to. Where is my? Okay. He's not there.
I think it's to the right.
This is the announcement. Okay. Well, it's not there.
Yeah, I think.
Oh, this is
No,
the
that's-
announcement. Okay.
To that one?
No. Okay. Anyway, I had a few slides I cannot show because apparently they were not on the server. I will them just from my list here. Okay. So my first question mainly to Brian, but Fred, you are welcome to comment too, is about, well, the fact that with the advent of these applications and the middleware, is it the end of a universal architectural model? We knew that 20 years ago or 25 years ago, the OSI reference model was invented. We know the shortcomings, the fact that there is an empty layer 5 and 6 almost, a crowded layer 7, no vertical layers were designed, middleware, the middleware layers do not fit. Now, we have new architectures proposed for grid, web services in a way. So, Brian, do you believe that this is actually the end of a single universal model? Do we need one? Is there any need for one? Does it help us understand what we are talking about, and where are we going in this direction?
Is this one on? Yeah. Those of you who've seen Steve Deering's talk about the hourglass model of the architecture can remember, and the rest of you have to imagine, that in his hourglass model, at the top, there is the piece called applications, and the architecture is very specific in the middle. You know, you have a few transport protocols, you have 2 versions of the IP protocol, and down at the bottom it's pretty specific because you simply have a long list of hardware mechanisms for getting packets from one place to another. But at the top of that model, it is really just, you know, an open cup at the top of the hourglass, which is full of application protocols. So if we stick to that as the architecture, then no, we don't get to the end of the architecture. But you know, we can still use that model. But I think what people should remember is that, you know, the current move with web services and grid computing is not exactly the first time that we've tried to solve the problem of distributed computing as opposed to the problem of networking. You know, Corba was the solution, right? I think Java RMI was the solution. DCE was the solution. ONC, which was proprietary, but that was also the solution. I think there have been a number of solutions to the distributed computing problem, and now we have a new one, which is the Open Grid Services architecture, which I think is it's a very sound architecture. But I would be amazed if it's the end of the story, and if it really is, you know, the solution we're using 20 years from now, let's say. So I think we are going to continue to have diversity at the top end of the model. I don't think that's going to go away.
Fred, do you want to comment?
I don't see how we can get away from diversity, but I don't know that that changes the ultimate architecture. The architecture as we have it today is that you have end stations sitting around running applications. And they have ways that they talk to each other through the network, and we all know what those ways include. And that isn't fundamentally changing. Where I do worry, when I talk with people in my own company and they say, okay, so let's take this application thing and move it down to layer 2 where we can look at it, I find myself saying, you know, there's got to be a better way to do things than that. And we certainly hear that kind of thing from various places. Whenever we move away from the idea of putting the application in end systems or things that will operate as end systems and doing the right thing with them in that context, we create problems for ourselves, serious problems, and we make the network very brittle, and all the things that are pointed to in the end-to-end arguments paper come out and they bite us big time. So I would say that no, we're not fundamentally changing the architecture, and we can't because it doesn't work. But we're certainly extending it in places of saying, so we're going to add some more bits and pieces here.
Okay. My second question is more directed to Fred, and again, Brian is welcome to comment too. It's about what seems to be a sort of eternal dilemma between when designing technology for communications and networking, stateless versus stateful systems. Systems usually lie on a sort of continuum, but usually only the extreme of those continuums are occupied. On one end, we have stateless systems, IP, HTTP. On the other hand, we have stateful systems, such as ATM or login-based transactions. And what we see is that with some of those systems make effort to drift the bit toward the other one. We see IP drifting with MPLS and RSVP to the other end, and ATM drifting a bit with ABR styles to the other end, but they remain at the end of the spectrum. Now the point is that what is a stateless system? A stateless system is a system which keeps a state, which keeps a memory, information and memory of the past. And the main problem is that when you have no memory of the past, you cannot predict the future. And this is what stateless systems are doing. You take a packet, forward it, forget it. You receive an HTTP request, serve it, forget it. Now, as we know, stateless systems, they scale well, but they are bad at quality of service. They have no reservations. But systems which are stateful with reservations, usually, they do not scale well, but they are good at quality of service. Now, I have not seen any real change in this dilemma over the past 20 years. We are still stuck with this problem. You are at one end of the spectrum or at the other one. And if you are at one end, you get the benefits, the full benefits and drawbacks of the approach. Do you see any change in the recent developments for this dilemma?
Well, I see a growing pragmatism. In this country, religious debates have been going on for hundreds of years. This country? The one that we're sitting in. And, you know, they wander around wearing green clothes and orange clothes on certain days of the year. And we know where religion, in that sense, brings us. And, you know, if you've read the paper or on the web recently, I got a notification saying, please don't go to Pakistan or India anytime soon. Religious things get in the way. And what this really is a question of religion. It's a question of how do you view the network and what will you be flexible and inflexible on. Now, when we talk about a stateful architecture versus a stateless architecture and so on and so forth, what we're really looking at is not the specifics of what one does or what one tries to do, but how one goes about doing it and how one thinks about it. If I'm in Los Angeles, California, and I put you on Highway 10 and I tell you to drive to Tallahassee, Florida, what you will do is get on Highway 10, drive for 3,000 miles, and wind up in Tallahassee, Florida. And so the directions that I might give you are head east until you see a large body of water. And you know, that's pretty much what we do in the IP internet. We give you a destination and we get you there. In the circuit switch world, we say, you're on Highway 10. Stay on it as long as there's a Highway 10. That will also get you from LA to Tallahassee, Florida, as long as no bridges are out. And it's exactly the same path. You'll follow exactly the same path and you'll accomplish the same result, but you'll think about it in a different way. When we choose only to think in one way or the other and to only look at those extremes, then we always have to give up something that the other is capable of doing. When we talk about lambda switching in the internet, lambdas are circuits. Trust me, they're circuits. When we talk about things having to be stateless, well, then maybe we can't do lambda switching because those are circuits. Is that okay? I have to say I think it's just fine. And why would I not want to do lambda switching and make the necessary accommodations in the way I approach the world in order to do that? So I think that we need to come to a pragmatic perspective of I can think about things one way and I can think about them the other, and sometimes I can mix, which is what we do with RSVP. We say there's a small set of applications for which I actually do need to tack up some bandwidth, and I need to know that the bandwidth is there. And there's a lot that I don't need to know, and certainly for other applications, quality of service has nothing to do with jitter, it has to do with rate. And so let's use the stateless models of diffserv for those. But, you know, for those applications that need it, by all means, we do in fact have to mark up the bandwidth. Otherwise, we'll run out. It won't be there when we need it. And we have to be willing to do both at the same time. Brian, maybe you want to add to that.
I agree with you. I think the other point is that pretty much everything that appears to be a stateless solution actually keeps state. It just doesn't talk about it.
Yeah, of course.
Keeps different state.
Yeah. This brings me directly to my third question before we open the questions to the floor. Because if actually the solution is sort of mix, the result is complicated. IP plus RSVP for reserving resources, plus probably MPLS for root stability, plus diffserv for marking packets and classify them rapidly. All that is complicated. You need probably the conjunction of the three, plus probably aggregated RSVP to simplify. So all that makes the plain old IP now a complicated technology. And so my first question is about, is it not, after all, the end of the complexity we should aim at? Because there is a fact of life in all systems, all human systems, that when resources are abundant, the systems to manage them can be simple. It's when the resources are scarce that you need complicated systems. And we all hear that the bandwidth will be plentiful in the future. So is it not the end of the complexity? Do we need all those complexity to manage resources which will be abundant?
In my experience, which, you know, it's limited. I've only been around this for 24 years. It seems like every time we make a promise that we will make the complexity go away, we make it go away in one place and it sprouts up somewhere else. It's what Randy Bush likes to call whack-a-mole. You push it here and it pops up here. We wind up adding complexity to the network for two reasons. One of them is perhaps because we don't think through well what it is that we want to do. And the other is because we actually need to achieve something that needs to be done that the simple system didn't do. And we find ourselves then always wanting to remove that complexity, but we still needed to do whatever it was. So no, I don't think the complexity is going to go away. We don't stop needing to do things. We're going to move it around.
Do you buy it?
I can give you a specific example. I've had some discussion with some people interested in building, the data parts of 3G networks. This wasn't a private discussion, so I can mention it. And they are looking at doing all kinds of signaling and bandwidth allocation technology on top of diffserv within the radio access network. And I said, why? Why don't you just over-provision? And the problem is, if you're running that sort of network, you have to deal with literally thousands of base stations, and you cannot afford to over-provision the connections between those base stations. Even in today's world of lots and lots of bandwidth, I'm sorry, if you're trying to build a network of that size, you can't afford to over-provision to the extent necessary. So they need the complexity to avoid having to over-provision.
Mm-hmm. Okay, thank you, Brian. I think it's time now to open questions to the floor. So if you have questions, you can move to the microphone here. Who has questions? Yes. Can you move to the microphone just here? And could you say whether you address your question to one of our speakers or to both or to none? If it is a comment.
Okay. It's a question really to both speakers, because both foresaw a move from client-server architecture to something closer to peer-to-peer. In a client-server architecture, the owner of the server is responsible for protecting themselves against hostile clients. In a peer-to-peer architecture, who takes the responsibility for protecting one peer against a hostile other peer?
There was a very interesting paper that was never actually published, I think, by Steve Bellovan and a couple of colleagues a year or two ago, called Distributed Firewalls. And it wasn't about distributed firewalls, by the way. It was about doing security in every single host. And they called it distributed firewalls to make the people who think that firewalls are the solution more happy with this concept. And I think that is the answer. I think it is every single host's responsibility to be secure, as it is today. Because if you trust your corporate firewall to protect you, this is a dangerous assumption.
I agree. At
at the end of the day, when you walk down the street in the bad quarter of town, you're on your own, and that's true of our computers as well. That said, I think that the network can often provide services to mitigate some of that, which is essentially what we do with firewalls. We have the network provide a service to mitigate some of the worst effects. And so we can purchase services to help us manage the risk. But at the end of the day, you have to protect yourself. You have to look out for yourself.
That doesn't work at the moment.
It certainly doesn't work at the moment. It certainly doesn't work at the moment. But what it means is, you know, in some future ideal world, before you agree to participate in a transaction, you need to receive a certificate that you're prepared to believe that says the person at the other end of this transaction, you know, is, you don't need to know it's Fred Baker, but you need to be told, you know, it's someone who's, you know, certified trustworthy by Citibank or whoever else you are prepared to trust.
Any further questions? Any further comment? Any last word? Oh, yes, please.
I guess maybe just to follow up on the on this thread that we've started, I can't help but wonder how Fred's son authenticates the other players in the multi-user game that he's engaged in, and assuming that, you know, people are going to continue playing those games years into the future, you know, are they really going to insist on identification via Citibank and before they start playing the game? I doubt that'll ever happen. So what's the, you know...
Well, I don't think it's going to be via
risk?
Citibank, because my son doesn't have a relationship with them.
Right.
But they are going to need some form of trusted authority. Now, what they do today is that trusted authority is the server that the game is in fact run on, and they essentially use web-style services in order to access that server, which means that server is one busy little machine. What that server wants to become, I would claim, is a repository for information that can be downloaded to the systems to allow the players to do that same function. And then it wants to be some form of trust authority, and we can discuss how to do that, but that's what it wants to be. You would authenticate yourself to that server, and it would now transitively say, I have authenticated so-and-so, and he can be part of the game. That now allows the people who manage the game to be able to say, you know, so-and-so isn't operating by the rules, he's no longer allowed, or whatever needs to be done there.
Yes, please.
Okay, I have a question to Brian. This is, you define it, web services as a middle box function. Why? And another may be related to this. Does web services model fit to the client server or peer-to-peer, end-to-end?
Yeah, I mean, I think the answer to your question is yes, both. I try to avoid accidentally using the phrase peer-to-peer, you know, because I believe it's extremely confusing in the way it's been used in the last 3 or 4 years. Since, by the way, the first peer-to-peer network that I'm actually aware of was something called ARPANET in 1969, and I think we've had a peer-to-peer network pretty much ever since. Just if you want to hear a little joke, advanced peer-to-peer networking was invented by IBM, not by CERN, because that was a marketing term that IBM used many years ago. So there is absolutely, you know, the way the phrase peer-to-peer has been used in the last few years is very confusing to me, because it doesn't actually mean anything. That's why I'm trying to say any-to-any rather than peer-to-peer. But I think, yeah, I think web services going forward has got to get away from this pure client-server model it's still going to be someone providing service for someone else, but, you know, any two systems could play either of those roles. In that sense, it is a peer-to-peer model.
as the web was initially. Everyone remember that when Tim Berners-Lee made his first proposal, the idea was that any client would also be a server, and any browser would also be an editor. And the first commercial release did forget, in fact, this balanced and view of the web. Any further question? Last question. If not, it's exactly 10:30, so it's time to close this session. I would like that we thank again. Okay, there was one. Sorry. Yes, one last question.
Well, since Brian in particular has placed such emphasis on web services, I believe there's legitimate concern about how the web services standards are going to emerge, and in particular whether they're going to be handed to us by our good friends, the several big vendors, or whether they'll be developed in an open fashion. I guess OGSA is certainly one answer to that, but it isn't clear that it's necessarily the web services industry's answer to that.
Yeah, I showed you my list of 50 standards organizations. The ones you're thinking of are in there. I actually share that concern, wearing my personal hat.
So we might say there's a challenge and opportunity for those of us in the room to make sure that happens.
Yeah.
Okay, let us close, and thanks again our two speakers.